Conjugates are expressions like the square root of a plus the square root of b and the square root of a minus the square root of b that differ only in the signs of the second term. So the second terms will have a plus and a minus sign as the only difference. When a and b are rational numbers, the product of two radical conjugates is a rational number. So if a and b are rational numbers, the product of those two conjugates, where the only difference is the sign in front of the second terms, the product is a rational number. I'm going to multiply these two conjugates, 5 minus the square root of 7 and 5 plus the square root of 7. So if we multiply those, just going to use the FOIL method or distributive property. Take 5 times 5, those would be the first terms. 5 times the square root of 7, those would be the outer terms of the FOIL method. Then negative square root of 7 times 5, those are the inner terms of the FOIL method. And negative square root of 7 times the square root of 7, those are the last terms of the FOIL method. Remember, FOIL method and distributive property are the same things when you're multiplying two binomials. Multiply through that, 5 times 5, that is 25. 5 times the square root of 7, negative 5 times the square root of 7, and then negative square root of 7 times the square root of 7, that would be the negative of the square root of 49. Simplify that, combine the like terms in the middle, 5 square root of 7 and negative 5 square root of 7, that would just be 0. On the end, the negative of the square root of 49, that is going to be negative 7. So you have 25 minus 7, and that is 18. 6 minus the square root of 12 times 6 plus the square root of 12. Again, multiply those two conjugates using the FOIL method or distributive property. Distribute that 6 through that second set of parentheses. So 6 times 6, the first terms of the FOIL method. Then 6 times the square root of 12, those would be the outer terms of the FOIL method. Then distribute the negative square root of 12 through that second set of parentheses. Negative square root of 12 times 6, those are the inner terms of the FOIL method. And negative square root of 12 times the square root of 12, those would be the last terms of the FOIL method. Multiply through that, 6 times 6 is 36. Then you have 6 times the square root of 12 minus 6 times the square root of 12. And on the end, the negative square root of 12 times the square root of 12, that would be the negative of the square root of 144. Simplify that, combine the like terms in the middle, 6 square root of 12 and negative 6 square root of 12, that's just going to be 0. Those cancel each other out. And on the end, the square root of 144 is 12, so it would be minus 12 on the end. So you're looking at 36 minus 12, and that is 24. Again, we multiplied these two conjugates together and got a rational number. Multiplied these two conjugates together, and again, got a rational number. Sometimes a denominator is a sum or difference involving radicals. If the radical expressions are square roots, you can rationalize the denominator by multiplying the numerator and denominator by the conjugate of the denominator. So we're going to rationalize that denominator by multiplying numerator and denominator, again, by the conjugate of the denominator. Remember, for something to be simplified, you cannot be left with a radical sign in the denominator. So you need to rationalize that denominator, make that denominator into a rational number, and the only way to do that is to multiply the top and bottom by the conjugate of the denominator, which is the same thing as the denominator, just a different sign between the terms. So we're multiplying the top and bottom by the square root of 5 plus the square root of 2. Whatever you do to the denominator, you also have to do to the numerator. So on top, 3 square root of 2 times the square root of 5, that would be 3 times the square root of 10. And 3 square root of 2 times the square root of 2, that is 3 times the square root of 4. In the denominator, you're multiplying those two conjugates. Here's what happens. That produces a difference of 2 squares. When you multiply two conjugates, that will produce that difference of 2 squares. You could go through the FOIL method and distributive property, but really all you have to do is square the first term, square the square root of 5, that is the square root of 25, and square the last term. If you square the square root of 2, that would be the square root of 4. And since you're multiplying two conjugates, just put a minus sign between them. That is that difference of 2 squares that I'm talking about. Like I said, you could go through the FOIL method and distributive property and waste that time, but if you're multiplying two conjugates, just square the first term, square the last term, and put a minus sign between them. So on top, in the numerator, the square root of 4, that is 2. In the denominator, the square root of 25 is 5, and the square root of 4 is 2. Just clean this up. In the denominator, 5 minus 2 is 3, and in the numerator, 3 times 2 is 6. Now, if you look at that numerator, there is a common factor in that numerator, and that common factor is 3. So you could factor a 3 out of the numerator, and the reason you want to do that is so that you can cancel that with the 3 in the denominator. So factor a 3 out of the numerator, be 3 times the square root of 10 plus 2. Just divide each term in the numerator by 3, and that's what goes inside the parentheses. And in the denominator, that's still 3. Now you can cancel those 3's because you have 3 multiplied by the parentheses on top, and you have 3 standing alone on the bottom. So cancel those 3's off, and you end up with the square root of 10 plus 2. But you want to move that 2 out to the front so it doesn't look like the 2 is under the square root sign. If you move that 2 out to the front, it turns out to be 2 plus the square root of 10. Going to rationalize the denominator of 3 plus the square root of 8 over 2 minus 2 square root of 8. Now your first thought might be, since that's the square root of 8 there, I'll just multiply the top and bottom by the square root of 2, and that'd make that into the square root of 16. Well, the problem with that is you still have a radical sign left in the denominator. Because when you multiply the top and bottom by the square root of 2, you have to multiply that 2 by the square root of 2, and you would still have 2 times the square root of 2 in the denominator. The only way to get rid of the radical sign from the denominator with this binomial involving that radical sign is to multiply the top and bottom by the conjugate of the denominator, which is the same thing as the denominator, just a different sign between the terms. So we're multiplying the top and bottom by 2 plus 2 times the square root of 8. That is the conjugate of the denominator. On top, you're going to use the FOIL method or distributive property. If you use the FOIL method or distributive property on top, you will get 6 plus 8 times the square root of 8 plus 2 times the square root of 64. In the denominator, you don't have to go through the FOIL method or distributive property in the denominator. You're multiplying 2 conjugates. When you multiply 2 conjugates, just square the first term, square the 2, that's 4. And square the last term, square the 2 times the square root of 8. That would be 4 times the square root of 64. Squaring the 2 and the square root of 8. So in the denominator, that is 4 minus 4 times the square root of 64. Clean this up, simplify this. That square root of 8 can be broken down into the square root of 4 and square root of 2. Square root of 64, that is 8. And in the denominator, again, the square root of 64 is 8. Keep simplifying this. In the numerator, square root of 4 is 2, so that'd be 8 times 2, which is 16 times the square root of 2. Also in the numerator, 2 times 8, that is 16. Back to the denominator, 4 minus 4 times 8, that'd be 4 minus 32. Keep simplifying 6 and 16. You can combine those. It'd be 22 plus 16 times the square root of 2. In the denominator, that is negative 28. Now, if you look at the numerator, 2 is a common factor of that numerator. So you could factor 2 out of the numerator, just divide each term by 2 in the numerator. You'd end up with 11 plus 8 times the square root of 2 in parentheses. Now, the reason you factor that 2 out is because that will cancel with the negative 28 in the denominator. So cancel the 2 in the negative 28, and you are left with negative 14 in the denominator. So it'd be 11 plus 8 times the square root of 2 all over negative 14. We rationalize that denominator by getting rid of the radical signs from the denominator, multiplying the top and bottom by the conjugate. We made that denominator into a rational number, which is negative 14. We got rid of the radical signs from the denominator. We need to rationalize the denominator of 4 plus the cube root of 2 all over the cube root of 2. So with that cube root of 2 in the denominator, we want to make that into a rational number. We want to get rid of the radical sign. So we want to make that 2 into a perfect cube. So to make that 2 into a perfect cube, I want to multiply by 4. That'll make it into 8, which is a perfect cube. So multiply the top and bottom by the cube root of 4. So if you take the top and bottom by the cube root of 4, the denominator, that's what we're aiming at, that turns into the cube root of 8, and that'll turn into 2, and the radical sign will disappear. Whatever you do to the denominator, you have to do to the numerator. So multiplying the numerator by the cube root of 4. Take the cube root of 4 times 4, that is 4 times the cube root of 4. And the cube root of 4 times the cube root of 2, that is the cube root of 8. In the denominator, cube root of 4 times the cube root of 2, again, that is the cube root of 8. So wherever you see the cube root of 8, that's going to be 2. So in the numerator, cube root of 8, that's 2. Move that out to the front so it doesn't look like it's under the radical sign. And in the denominator, cube root of 8 there is 2 as well. If you look at that numerator, 2 is a common factor in that numerator. So if we factor a 2 out of the numerator, you'll be able to cancel that with the 2 in the denominator. So if you factor a 2 out of the numerator, divide each term in the numerator by 2. So if you divide 2 by 2, that is going to be 1. Divide 4 times the cube root of 4 by 2. That's going to be 2 times the cube root of 4. And now you can cancel the 2 in the denominator with that 2 outside the parentheses in the numerator. So if you cancel those, you would be left with 1 plus 2 times the cube root of 4. Going to rationalize the denominator of 5 plus the 4th root of x all over the 4th root of x. So to rationalize the denominator means that we're going to get rid of the radical sign from the denominator. Right now in the denominator, you have the 4th root of x. So we're going to multiply the top and bottom by the 4th root of 3 more x's. So to multiply the top and bottom by the 4th root of 3 more x's means you're going to multiply the top and bottom by the 4th root of x to the 3rd. Because in the denominator, what we're aiming at would turn out to be the 4th root of x to the 4th. And that's just going to be x. The radical sign is gone. So in the numerator, if you multiply that by the 4th root of x to the 3rd, 4th root of x to the 3rd times 5 will just be 5 times the 4th root of x to the 3rd. And the 4th root of x to the 3rd times the 4th root of x, that would be the 4th root of x to the 4th. In the denominator, 4th root of x to the 3rd times the 4th root of x, we already said this is going to be the 4th root of x to the 4th. Now you have 2 of those. 4th root of x to the 4th, that's going to be x. So it'd be 5 times the 4th root of x to the 3rd plus x. Move that x out to the front so it doesn't look like that x is under the radical sign. So it'd be x plus 5 times the 4th root of x to the third all over x. Those x's do not cancel. You can only cancel if it's multiplied by something else or standing alone. On top, the x is being added with that 5 times the 4th root of x to the third. So that is completely simplified. X plus 5 times the 4th root of x to the third all over x.